Hello everybody. In this video, I want to talk to you guys a little bit about solubility. Solubility is the degree to which really a solute is able to dissolve in a solvent, right? It's actually true that some solutes can only dissolve to a small degree in any given solvent, so you can only fit just a little bit in there, at which point no more will dissolve. Or we've seen that there can be things that are infinitely soluble where we can just keep adding more and more to the solvent and it will keep dissolving to the best of its ability. When we have a soluble solute-solvent pair, that means that a appreciable amount of solute is able to be dissolved in a solvent. We call them miscible. When only a small portion of solute will dissolve in a solute-solvent pair, we call them partially miscible. And when a solute just does not dissolve in a solvent, it is called immiscible. So saturation, as I alluded to earlier, there is a set amount of solute that can be dissolved in any fixed amount of solvent, and this is dependent upon the temperature. So if we tried to graph this out with temperature on the x-axis and the mass of solute that's able to be dissolved on the y here, we're going to see roughly a line. It doesn't have to be a line, but in short areas it kind of appear to be a line, where we reach the maximum amount of solute that can dissolve at any given temperature. And it's going to go up and up in this case, say like a solid dissolved in a liquid. And when we have a solution where we've dissolved the maximum amount of solute, we call that saturated. Anything that is not saturated, meaning we still have more solute we could fit, is going to lie below this line. And it is actually possible to fit more solute than can actually be sustained within a solution, in which case we create a supersaturated solution, which is a little bit of a weird idea because I told you that this was a maximum. What it really is it's a maximum if you allowed the solution time to settle. Eventually, any supersaturated solution is not going to be stable, and some of the solute will start to precipitate out until you reach a saturated solution. So the easiest way to get to a supersaturated solution is to actually heat a solution and keep adding solute until you get it saturated, and then allow it to cool really slowly, at which point it will take time for those solute molecules to find each other and start to crystallize out. And for some time after that, you will have a supersaturated solution. And this process could actually be really, really slow. There's some exotic examples where you have a supersaturated solution that just simply will not come to equilibrium except for after like years and years and years. But for the most part, it's usually a pretty quick process over the course of a few hours. So you guys are going to have a section in your homework that talks all about the solubility rules for ionic compounds in water. And I'm not going to talk much about this. We've seen that solubility is a spectrum, and there's a lot of cases, but there are a few hard and fast rules that you can use to decide whether or not something's going to be soluble. Typically, if it has one of these guys as the cation, it's going to be soluble. It's going to be soluble if it has a fluoride anion, except for in the cases of lead and iron. It's going to be soluble if it has chloride, bromine, or iodine anion. except for in the case when you pair that with silver or mercury or lead. It's going to be soluble if it's a sulfate, unless you have silver or barium or calcium or mercury or lead or strontium. Typically, the other polyatomics are always soluble. And then so is going to be true for some of the other polyatomics here, carbonate, chromium, sulfide. Whenever we see them with group 1 metals and ammonium and stuff like that, these guys are going to be soluble. And then the hydroxides are going to be soluble when we see them with group 1 as well. So you're going to have a few questions on your homework about this, and this table is basically going to be all your solutions for that. You just kind of have to get into it and realize how you're going to go about reading it. And we're also going to have a lab on this, and there's another good table in there to help you out with these types of problems.